Hello and welcome to Simplified Learning, and today we are going to take a look at some important multiple choice questions from the subject Project Planning and Management, and the topic in the focus is going to be Network Fundamentals and PERT. Alright, so let's go to question number 1. So we have been given some statements regarding rules of network, and the statements are: a network diagram has only one initial node and only one final node, and we are going to tick whichever statements are correct, and we are going to select the option accordingly. So the first statement looks to be good. Okay, it is correct because a network diagram has only one initial node where the network will be starting and it will be ending on a one final node. Second statement, time flow is taken from right to left. See, this is wrong because whenever we are drawing a network diagram, we draw it something like this, and the time flow goes from left to right. We start from left and we end up at the right end, right? Then network looping is allowed in some cases. See, this is completely wrong because we never allow any loop in a network. Okay, if loop is there, then the activities and events are going to be looping from that specific loop or path only. It is going to be a cycle. That's why we don't want that cyclic error or that looping error in our diagram. That's why statement 3 is false. Thereby, looking at the option, we can see only option 1 is true. All right. So let's go to the explanation side. See, a network diagram has only one initial node and one final node. Then the flow of network diagram is taken from left to right. Just like in this diagram, it starts with left end with left node and it will be ending at right. Thereby, the time flow is going to be left to right. Then network looping is never allowed. Okay, network loop is there. If a loop is there, if a cyclic error is there, it is not going to make the network diagram progress anywhere. That's why it is not at all allowed. So let's go to question next. Alright, the question in front of us is, what type of error is there in the following diagram? See, as long as we can see the diagram, it is going well, but when we are looking at this point, activity D, the thing is, it is not progressing anywhere, or it is not having its path inside the network diagram. Means it is out of the diagram. Now, if you carefully see this one, then looking at the option, it is not looping or cyclic or wagon wheel error. It looks like it is hanging in there. Okay, means having that activity D is not having any impact or let's say any contribution, because if we can remove this one, if we can get rid of this one, it is not going to impact the flow of the diagram. Thereby, it is hanging in uncertainty, it is dangling in uncertainty. That's why this specific error is called as dangling error. All right, activity D is not having any progression or is not having any logical path inside the network diagram. It is there in the diagram, it has no progression or it is not connected with any other event or activity which is there in the network diagram. That's why we will be calling it as hanging one. Okay, it is hanging in there without any certainty. That's why it is called as dangling error. Okay, now since we have seen this dangling error, let's see other type of error in this explanation only. One is looping or cycling error. Okay, just we saw a question where we had that statement that looping is allowed. No, looping is not allowed, and once looping can be seen, it will be causing error. Okay, another one is wagon wheel error. Now let's see this dangling, looping and wagon wheel error one by one. See, in this diagram, the activity D is a hanging or a dangling error. Duration of activity D has no effect on project completion, means its existence is not causing any effect or is not having any dependency in the network diagram. That's why it is called as dangling or hanging error. Then other thing, looping or cycling error. All these activities are into, all these events are into a never ending loop. Thereby, they are not going to progress. They are not causing any completion or finish of the project, or let's say that phase of the project. That's why they are called as looping or cyclic or cycling error. Okay, they are looping like this. Okay, never ending loop is there. Then other thing, other error, wagon wheel error. See, in the diagram, we can see activity A, B and C are coming to an event, and after the specific event, 3 more activities are emerging. See, if we are not properly maintaining logic of the network diagram, then there may be an event which will be having some event that, sorry, some activities that need to be completed so that some more activities can take place. This kind of dependency means, see, A, B, C, 3 activities need to get completed in order to initiate activity D, E and F. This is kind of error where the planner has not put his total effort to make the activities separated or to remove that much dependency from that network diagram. See, 3 activities not able to start until 3 previous get completed. This may not be an actual scenario. This kind of dependency means 3 activities need to be completed in order to start 3 newer ones. This kind of dependency may not be there in the network diagram. This may be because of this may be on the part of planner. That's why this is also an error, wagon wheel error. Generally, wagon wheel error are difficult to spot, but we can see that specific event is having lot of activities onto it, and after that activities get completed, another lot of activities are getting started. These many activities are not supposed to be dependent on one event, right? Then identify the element highlighted in the following diagram, respectively in diagram A, B, and C. All right, diagram A is there, B is there, and C is there. Diagram C is easy one because the thick line part shows what? It is nothing but critical path. All right. Then let's go to diagram A and B. If we can see this event, okay, this specific event is causing 3 activities to merge over there, okay, to conglomerate over there. Thereby, this will be called as a merge event. Okay, it is causing activities to merge down together. In diagram B, we can see this specific event is trying to give birth, or it is bursting with some activities. Okay, D, E, F. It will be called as what? Burst event. Thereby, looking at the option, what we can see, it is nothing but merge event, diagram A, burst event, diagram B, and critical path. All right. See, when one or more activity are coming and joining together at an event, it will be merge event. Activities are bursting out, they are leaving that event, it will be called as burst event. Critical line, whenever there is in network diagram, it will be shown with this thick line. Okay, let's go to question next. Okay, what skip numbering is there in a network diagram? See, whenever we are looking at a network diagram, it generally starts with, like, let's say 1, then 2, 3, and 4, and so on. But in case if the project is large and we come to know that later on in the project some activities, some event need to be added. Okay, means in short, modifications have a lot of scope in a project diagram when it is relating with a large project. In that case, we cannot just restructure or start from scratch for drawing that, or let's say for planning that network diagram. In that case, what we can do, we will be starting the initial event with 10. Okay, then we will be progressing to 20, or let's say 30, like this. A float will be there like this, then like. All right, now what is the advantage of having 10, 20, 30 over here? See, when there was 1, 2, 3 over there, and we had to add an event number, let's say 5 in between, or let's say we had to add an activity, or we had to accommodate an activity or event in this specific diagram, then it would be necessary to totally restructure, reconfigure the diagram. But what we are doing now is, we will be putting activity 11 in between if we, event 11 if we need to, or we can put event, let's say, in between 30 to 40 if 4 events are meant to be there, and we can add 31, 32, 33. Means without disturbing the original diagram, means the exoskeleton, or let's say skeleton, the framework of the network diagram is ready. And in case we have to accommodate any event or activity in between in the existing diagram, we can easily have that, right? Means from event 10 to event 20, we have to accommodate some event or activity, then we can number them 11, 12, 13, 14, 15, up to 19, right? Means 9 event can be added in between those two event 10 and 20. Thereon 10, 20, 30, 40, the sub events, or let's say the sub activities, can be added. It means the network diagram need not to be disturbed totally from scratch. We do not need to draw it. We can have all the accommodations inside the existing network diagram only. Thereby, this is the advantage of using numbering like 10, 20, 30 instead of the conventional numbering, which is 1, 2, 3, 4, right? So the option should be C. It is the method of numbering in a large project so that event can be added later with numbering between the double digit. See what we say, 10 to 20, if some event need to be added, the first event will be numbered as 11, the second will be numbered as 12, right? Up to 20 we can do that, up to 19 we can do that, till we get to event 20. But practically we won't be needing the number 19, see, because the planner will be taking that much care so that not that many events get added later on. Okay, so option is C. Skip numbering, it is done in a large scaled project network. See, event number 10 is there, 20 is there, 30 is there, 40 is there, 50, 60. In between, if we need to add any event, we can add over here like 11. Here we can add 30 to 50, we can add something over here, we can add something over here, right? Means having the numbers 10, 20, 30 make space for accommodating those new events and activities. Alright, then we are having terms and definitions over here. What activity is, what event is, what float is, what dummy is, and what dangling error is. Okay, now the good thing about match the pair kind of MCQs is that if we know more than 50% or if we know even 1 or 2 or 3 pairs correctly, then we can logically match the other pairs. Now, what do we know about activity? Activity is what? It is a task that uses time and resources. Thereby, A gets matched with 5, right? Then what an event is? What an event is? B, a milestone or significant point. Okay, B is 4. Then what a float is? Float is a time or a task that can be delayed without impact. Okay, we can match it over here. And what a dummy is? It is a fake task for maintaining logic. To maintain or to preserve the logical flow of the network diagram, we add what? Dummy. Okay, D with 1. And finally, we are having the dangling error we just saw in previous question. Dangling error is nothing but an error where a task has no link, an activity has no link. Thereby, we can see here that A with 5. Okay, A with 5, option Q is bearing that similitude. A with 5, B with 4, C with 3, D with 1, E with 2. Okay, since A with 5 is the only pair and we have matched it correctly, we can directly tick the option. But in case A with 5, if that would have been in other options also, we would have to check the remaining options too. All right, whatever the definitions we saw, it has been mentioned over here. Then we are into PERT. Okay, see, select the incorrect statements regarding PERT from following. PERT is employed in non-repetitive project. Okay, now we have to select incorrect. But this one statement is correct. PERT is employed in non-repetitive project. Means in case the project is research and development kind of project, it is a PERT project. All right, this one is right. PERT uses probabilistic approach. Yes, since there is no historical data, evidences or already experimental data available for the PERT project, we will be using probabilistic approach. Then PERT has more focus on event than activity. Yes, completion, milestones and those events have that significance in PERT rather than activity. This one is also correct. PERT is best fit when historical data is not available. We just saw it. Okay, since it is using probabilistic approach, it is the case where historical data is not at all available, experimental data is not at all available, there are no evidences regarding that specific project. That's why we will be employing PERT over there. And thereby, since all the options are correct, we will be ticking option D. Okay, all the statements are correct. That's why none of the above statement is incorrect. All right, see, PERT is employed in R&D type of project. Probabilistic approach is used where no historical supporting is there, no existing data is there. Then PERT has more focus on event. Then PERT is best fit when historical data is there, R&D kind of project is there, and projects such as time estimate required or project duration is required. All right. Then we are having 3 columns and we have to match the pairs. In terms, we are having optimistic time estimate, then most likely time estimate, then pessimistic time estimate, and the symbols are there. Now first we will try to match the symbols, then we will be matching the definition for those specific terms. So let's look at optimistic time estimate. Optimistic time estimate is denoted by T suffix O. Okay, it is like this. Most likely is denoted by T suffix M, and pessimistic is denoted by T suffix P. Okay, this half portion is done. Now we have to match the definitions with these symbols, or let's say with these terms. Now if we look at definition, then when we are looking at optimistic time estimate, which is TO, TO is nothing but the minimum time required. Optimistic means the least time that will be required for an activity without any delay, means no delay, no worries are there in the completion, thereby it will be the minimum time. Okay, then most likely time estimate, okay, T suffix M, then it is nothing but realistic estimate, okay, the most practical estimate for time required for an activity, and T suffix P will be the maximum time with all the possibilities that everything will be going wrong with the activity. Okay, thereby with this we can see A is paired with 3 and with statement 2. Then B is paired with 1 and in third column it is paired with 1. Okay, thereby we are having this 2 A32 B11 A32B11. Yes, option A, or let's say option P is here. Okay, option P makes up the correct option here. Alright, optimistic time estimate TO is the minimum time required for an activity without any delay. Okay, we are not planning for any delay or no mishap in the activity completion. Then most likely time estimate, it is denoted by T suffix M or T suffix L. Okay, likely. Okay, it is the realistic estimate. Okay, but the most practical thing we can have. Then pessimistic means, let's say every bad aspect happens when we are trying to complete that activity, it will be pessimistic time estimate TP. Okay, all the possibilities of everything going haphazard or it is going for a toss. Alright, we are having assertion and reason, and we need to tick the option where either we will be having A and R are true and they will be related, or A and R are true but they won't be related, and then either of them will be false. PERT makes use of deterministic approach and it makes sure that project completion will be timely and within schedule. See, we just saw PERT makes use of not deterministic but probabilistic approach. Okay, probabilistic approach is adopted by PERT. Thereby, statement A, that is assertion, is false. Then the reason, okay, or let's say statement 2, time estimates are done when with deterministic approach, imply that planner had historical data available with him and he had sufficient knowledge about the inbound activity. See, this is not the thing with PERT, but time estimate when the deterministic approach regarding this. With respect to deterministic approach, this is the way planner does his work. Okay, thereby reason is true, or let's say not reason, statement 2 is true. Thereby we will be ticking option A is false, B is true, that is A is false, R is true. Okay, statement 1 is false, statement 2 is true. Yes, what we saw, PERT makes use of probabilistic approach. Okay, then the time estimates are done with deterministic approach only when we are having what? Historical data, evidences, okay, experimental data. Alright, select the correct statement regarding optimistic, pessimistic, and most likely time estimate from the following. Most likely time estimate are more realistic than optimistic and pessimistic. This is correct. Okay, this is the practical approach. Then pessimistic time estimates are shorter than optimistic time estimate. No, this is not right, because we are not having a correct thing regarding that pessimistic time, because pessimistic time estimate is obviously longer. Then optimistic time estimates are often larger, often the longest. No, this is wrong. Then expected time required for an activity is the weighted average of TP, TM, and TO. Yes, this is right. Okay, thereby we should select option 1 and 4. See, most likely time estimates are more realistic. This is right. Pessimistic time estimates are longer. Optimistic time estimates are often the shortest one than what? Most likely and the pessimistic. And expected time required is the weighted average of this TP, TM, and TO. So that's it for the video. I will see you in the next one. Till then, take care. Bye bye.